Dear students, let's derive the electric field due to a uniformly charged thin spherical shell. So, a thin spherical shell irukku. Center is O, radius is R, and uniformly charged. For example, positive charge, okay, uniformly charged. It creates an electric field everywhere, which is radially outwards. Okay, இப்போ நம்மளோட aim என்னன்னா at some point P r distance from the center of the shell, what is the electric field? That's our aim. அதனால நம்ம என்ன பண்ண போறோம்? We are going to use Gauss law. Gauss law யூஸ் பண்ணனும்னா நம்ம என்ன பண்ணுவோம்? First Gaussian surface வரையணும். So Gaussian surface எப்படி வரைய போறோம்னா a surface which goes through that point P. ஓகேவா? ஸோ இப்படி another sphere, இது வந்து சர்க்கிளான்னு படத்தில் காமிச்சிருந்தாலும் இது வந்து என்னது, இட்ஸ் ஆக்சுவலி a sphere of radius small r. Okay, so this one is Gaussian surface. இப்போ Gauss law எழுதலாம். Gauss law என்னது? phi equals q divided by epsilon naught. The charge enclosed by the Gaussian surface divided by epsilon naught. Inga charge vandu, it's uniformly distributed on the shell. So we can write this in terms of the sigma, that is surface charge density. So how do we write surface charge density? Sigma equals charge per unit area. Okay, so we are going to multiply these two and then we will write here sigma times A divided by epsilon naught. Here A is the surface area of the shell. So we can write phi equals sigma into, what is the surface area of any sphere? It is 4 pi r squared. R is the radius of the shell divided by epsilon naught. So let's keep this as equation 1. இப்போ நம்ம என்ன பண்ண போறோம்னா flux என்னன்னு calculate பண்ணிட்டு flux going through the Gaussian surface அது calculate பண்ணி we are going to substitute it here. For that, if you observe here, you just take a small area on the Gaussian surface, let it be delta S, and then the electric field also will go in this direction and delta S also will be in the same direction. So they both are actually parallel. So let us write flux equals E dot delta S. Both of them are parallel. So E delta S cos 0. So that will be E into delta S. So like this small area only we have taken. If you consider the entire Gaussian surface, we have to sum all the surfaces. So for that we are going to write phi equals E sum over delta S. Okay, this sum over delta S is the surface area of the Gaussian surface. Surface area of Gaussian surface. Gaussian sphere also you can say. Okay, so here surface area of the sphere is E into 4 pi r square, because the radius of the Gaussian surface is small r. So we have to write 4 pi r squared. So keep this as equation 2. Now substitute equation 2 in equation 1. So substitute பண்ணும்போது we can write phi. Earlier we had sigma 4 pi r squared divided by epsilon naught. So we are going to write that here. Sigma 4 pi capital R squared divided by epsilon naught. Now we are going to write this as, instead of flux, we are going to write E 4 pi r squared, which is equal to sigma 4 pi capital R squared divided by epsilon naught. So from here, if you see, this is a 4 pi and 4 pi will get cancelled. You will write E as sigma r squared divided by epsilon naught r squared. So this is the electric field at point P, r distance from the center. From the center, r distance from the center. Okay. Now, instead of writing sigma, if we represent this flux in terms of charge itself, okay, so how do we write flux equals q divided by epsilon naught. Okay, and now instead of phi, I'm going to write what we calculated, E 4 pi r squared, right, which is equal to q divided by epsilon naught. Now from here, if I write E equals q divided by 4 pi epsilon naught r squared. This is very similar to the electric field due to a point charge. Due to a point charge. அப்படின்னா என்ன அர்த்தம்னா, the uh, electric field outside the surface of this thin shell, electric field at all points outside the shell, the electric field is as if all these charges are acting at the center, that is Q. So that's why we are getting the similar electric field due to a point charge. So this is the electric field due to the point charge which is kept at the center of the shell. Now let us do the same thing for electric field at a point inside the shell. So for that, we are going to draw the shell like this, and the center is O, radius is R. So we are going to find out at some point P, which is R distance from the center, we have to find out, this is point P, what is the electric field. Okay, so first we have to draw the Gaussian surface which goes through this P. Okay, so this is Gaussian surface. Now let us write Gauss law. So Gauss law is phi equals q divided by epsilon naught. This is the charge enclosed by Gaussian surface. Enclosed by Gaussian surface. So here, look at this picture. This the charge is everywhere. It is out of the Gaussian surface. So inside the Gaussian surface, there is no charge. So phi equals 0, which means that phi equals E dot A equals 0. So which means that electric field inside the spherical shell is 0. That's all. Thank you.